Oh, you know. It's like at the beginning of the thing, and then the rest is like.
Okay, look at 17. Listen, addressing Luke's concern about the difficulty of the packet. Really, it's like everything else we've done this year. If you will focus on the big picture, make sense of the big picture before you worry about little steps, you'll be fine. Just don't do it the other way around. Don't say, oh, I'll worry about big picture later, just show me the steps. Then things get confusing very quickly. So here's the big picture. They say consider the differential equation. Okay? I don't think we've ever seen a problem this year that said differential equation, but it's not a new idea. A differential equation is just an equation where one or more of the terms in the equation is dy dx. So you've seen equations like this all year long. Okay, they just haven't given it a name. Okay, so it's called a differential equation. Sometimes they use the word, sometimes they don't. Okay, but anyway, that's all they're saying. Good to there? Okay. Then it says find the particular solution. They call that particular solution y, or they call the solution f of x. It does not mean, look up, come on. The equal sign doesn't mean that y becomes f of x. It means that the solution could be called y, or the solution could be called f of x. Just two different ways to name the solution. Yeah, perfect. Okay, Danica's chart is a really good way to see the big picture. They're giving you a rate right there. They're giving you a rate. And when they say find the solution to the differential equation, they're asking you to find the equation for calculating the amount. So they're giving you an equation for calculating the rate, and they're asking you to find an equation which can be used to calculate amounts. That's why over here it says we're looking for y equals something. I don't really know what that is yet. Or perhaps I'm looking for f of x equals something. Okay, that's the big picture. It's a really simple idea. They're giving you this equation. They'd like you to find this equation. That's all. So whatever the words are, that's all they're talking about. The solution to the differential equation is simply this equation. Question? Cool. One other thing they mention is that this equation, whatever equation you come up with, it has to be able to do this. You have to be able to plug in a x equal 1 and get a y value of 0. So that's the requirement of the problem. Okay, I'll pay somebody a full ticket. If you're understanding the big picture, you should already have an idea of what we would kind of generally want to do to get from this equation to this equation. Say, antiderivative. So really, the big picture should feel simple. It shouldn't feel complicated. Now, they have one barrier to simply doing an antiderivative. Look at this equation and notice. This equation for dy dx contains both the input variable and the output variable. The input variable is x, the output variable is y. So because the equation contains both variables, you cannot simply find an antiderivative. So the idea that Sage mentioned is the right idea. We want the antiderivative. It's just not that straightforward. It requires a bit more work. So memorize the following. When you need to go from this to this, with an antiderivative, if your derivative has both the output and input variable, you're going to have to use this method. So the method is standard math. The little acronym is my acronym. You can pronounce it however you'd like. I prefer the SASSY method because it makes people smile when I say the SASSY method. It sounds all edgy and stuff. SASSY method. Questions? Good? Cool. So we are trying to solve the differential equation, which means we're trying to go backwards to find this equation. Because the differential equation contains both the output variable and the input variable, we have to use the SASE method. The S stands for separate. The S stands for separate. We have to separate input and output variables. And because we like to end up with y equals something, we're going to put all of the output variables on the left and all of the input variables on the right. We need to separate the variables. Questions? Cool. Separating it's really easy because the first step is to simply multiply both sides by dx. Trying to transform this equation into this equation. Because there's both input and output variables, we first must separate the variables. Question? So multiply the dx across. Now I'm going to multiply both sides by 1 over y minus 1 squared. Questions?
Why did you do 1 over?
I wanted to move the y to this side. I don't really care about the -1. That's a constant, so it just kind of goes wherever it goes. And the way I separate typically is by multiplying or dividing both halves of the equation. So if I multiply this half by 1 over y minus 1 squared, these two will divide to make 1. I have to do the same thing to this side. That's why I got that. Is that a question? 2 points. Anybody else? Cool. Okay, for separating, you've probably earned 1 point already. It's in FRQs, so you get points along the way. We have separated. The entire left is only values of y. The entire right is only values of x. So we have separated. So next thing. A stands for antidifferentiate. So you apply the antiderivative operator to both halves, like so. This half, I recognize kind of a problem as written, because I cannot use the ln rule. The ln rule doesn't work because of the squared. Questions? So I'm going to move and rewrite it like this. Questions? Okay, the other half, I can find the antiderivative because this is the cosine of ax plus 0. So the antiderivative of the cosine is the sine, or 1 over a, multiplied by the sine of ax plus b, like that. Want to talk about anything to this point, please?
Why did you do the expanded?
On this one here. So when you look at the rules, they're really, really specific. So the most basic rule will only work if you have the cosine of just x. Or like the cosine of just t, dt, things like that. Does that answer your question?
Yeah.
2 points, Lou. Sorry, Lou.
Is it possible to to have another problem that's similar to this, but it actually actually has limits?
Oh, really good question. No, not for our class. If we're using the SASE method, we're only anti-differentiating. Yeah, we won't be integrating. Really good question. There you go. You're welcome. Okay. This side I use the expanded rule again because I have 1y plus -1. So the antiderivative is 1 over a, ax plus b, the -2 plus 1, divided by -2 plus 1. This side, nothing to be done but rewrite to maintain equality. Questions? Wait for pencils, so people don't rush. Okay, next thing. So we have now finished the antiderivative step. We probably earned 2 points for that. If you check the back, the answers are in the back. But so far we've probably earned 3 points. Just a reminder, I told you how many points to get a 4, right? 60. And how many total points? 108. So we got 3 out of the 60 here. So this is a good problem to work on. It's like it's going pretty smooth, nothing complicated.
Were those are those the integral lines?
The antiderivative.
Okay, so that's just showing that you're doing
Right. So what I had was I had the blue equation, which came from separating. And then the next step is to anti-differentiate both halves. So I anti-differentiate this side, anti-differentiate this side. 220. Say your question, Mario.
Yeah.
Okay. Pretty good to hear? Now I got to remember big picture. The big picture is you're starting with this equation. You're trying to find this equation. If you were to take the derivative of this and rearrange a little bit, you get this. Got it? So that means this equation could have ended with something like plus 3. And when I took the derivative of this equation, the derivative of 3 would have become 0. I would not know what happened to it. Like it won't show up over here. When I'm going backwards, I have to account for the fact that there might have been something. So just like when we're finding antiderivatives, we use the rules. When we're all done, we just remember, oh yeah, we could have had a plus c. Like that. So we're not done yet because the goal is to get y equal. But we're close because we don't have this dx and dy stuff anymore. Please.
Could you do plus c on both sides because you've got the antiderivative on both sides?
Remember that the plus c is just a reminder that we started with something, took the derivative, and so if what we started with ended with a constant, that would have disappeared. So we don't really need to put a plus c on both sides. It's like, well, we had a c somewhere. That's all. Does that make sense? 2 points.
Why did you have to see when we're not done yet? Like,
Oh, gotcha. Hold on. In an antiderivative question, we wait, right?
Yeah.
We like do everything, and at the very end we go, oh yeah, plus c. Here, it's kind of related to what Sage said earlier as well. There's an added complexity. The added complexity is that we have to figure out a formula so that when we plug in 1 for x, we end up with 0 for y. And the c helps that happen.
okay.
So I have to add it in now because I'm actually going to go find it.
Okay.
That's what the c is for here. So we've done the separate, the anti-differentiate. Now we need to work on the constant. Question? Now I thought it would be clever and easier to remember if all of these words sounded the same. So I've got separate, anti-differentiate, and now I have to have a made-up word, so don't laugh too hard. Constantate. Gentle smiling is helpful. Yeah. Constantate. It makes sense. Friendly's guys. So separate, right? Anti-differentiate, constantate. Verb means to find the constant. Please share that with your AP Lang teacher, Mr. Reese, will love that. So, constantate, to find a constant. So, put it in your flashcard deck. Okay, never mind. Question? So now we find the constant. It's really easy. We probably got to clean this up though. So that's going to be, let's see, that's to the -1. So I have y subtract 1, the -1 power, divided by -1, equals 1 over pi sine pi x plus c. Question? Look over here. Okay, when I have, look, this is just this type, divided by this. Divide by -1, multiply by -1, same thing. So I'm going to mentally just pull the -1 out of the way. Don't think about it. I don't like negative exponents. It makes the problem harder. So I'm going to move that to the bottom. But the -1 is just a multiplier or a divisor. It doesn't matter. So I'm going to write this as -1 divided by y subtract 1, the first power, like so. Question? Okay, raise your hand if you can see what we're going to do to determine the value of c. Think a big picture again. You start with this equation, trying to get this equation. But whatever this equation is, it has to be an equation where when you plug in a 1 for x, you get a 0 for y. So what do I do over here to figure out the value of c that will make that happen? Show me your hand. If your hand isn't raised, talk to someone who does have their hand raised. One big hint. Hands down for a second. Look out. Hey, one big hint. One really big hint. We started with this equation. We're trying to find this equation. Not if that still makes sense to you. Okay? We have the equation we need. It's right here. Like this is the equation we've been looking for. It's just not rearranged to say y equal, but it is the equation. But we need to know what number goes here to make it all work. So how do I find c? Hands, come on. How do I find c?
Plug in 1 for x, plug in 0 for y.
Yeah. So this equation has to be an equation where, because this is this one here. Like they're the same thing, it's just not rearranged. And this equation has to be an equation where when x is 1, y is 0. So I'm going to force c to be the right number to make that happen. So I write -1. How many knew it? 2, 3 for Kate. Please don't forget, whenever you replace a variable, use parentheses to avoid mistakes. So in place of the y, 0. Place of the x, 1. Question? It's copy this so I can keep working. Okay, get rid of all this. That's not what I wanted. Get rid of this. Okay, so now I have over here now I need my watch. So I look at my watch. An angle of pi is right there. Okay. Cosine looks like the word across, so I know that cosine is the left or right. Sine is the up down. From the center to here, I do not go up or down, so this right here is 0. Question? So I'm looking at my watch. I remember an angle of pi is right here. Cosine looks like the word across. So the cosine is the left or the right. Hence, sine is the up or the down. But to get from here to here, I don't go up or down. So this value is 0. Sine of pi is 0. 2 points. If you still feel like you're struggling with the watch, I don't want to call it the unit circle, that brings up bad memories. Call it the watch. If you're struggling with the watch, just really come talk to me, I swear, for 3 minutes. And if you just talk and I listen, you'll get it. And you won't ever have trouble.
So if it was cosine of pi, then it should be negative.
-1. Because cosine looks like the word across. And you're going to the left, so -1. Points for Mario. Anyone else? Awesome. So that's all 0. Let's see, -1 divided by -1 is 1. So C is the very exciting value of 1. Questions?
Is that all we're finding?
No, remember the big picture was, they said consider the differential equation, and they said find the solution y, or f of x, to the differential equation with this initial condition. So our ultimate goal is to end up with y equals something, but along the way we did have to find c. So we're not finished, but we're close.
Which is sine of pi is 0. And then
0 times 1 over pi is 0. Points for Sage. Hey, you can check the back to make sure. But this problem is likely worth, so far, 1 point for separating, 2 points for anti-differentiating, and 2 more points for constantating. Okay? In the back, they won't say constantate, of course. They'll say finding the constant, and they'll also say using the initial condition. We've done both of those. We plugged in the initial condition, as Kate told us to, and then we found the value of C. So we've earned 5 out of 60 points so far. Like, our goal is 60. Our goal isn't 108. You don't want to try and get all the points. It's a bad strategy. You want to get to 60 as fast as you can. So you want to collect points as quickly and easily as possible. It's a really good example of how you get 5 of those points already. All right? Question? That means you're almost a 10th of the way there on one problem. Okay.
How much of a multiple choice is it? Are we looking 1 or 2 questions?
Every multiple choice question, if done correctly, will earn you 1 1/4 of a point.
So if you were doing this problem on the test, and then you ran into a problem and you didn't know where to go, but you've already done most of the steps, if you don't finish it and get a final solution, will it still give you 0.5?
So if I can get to where I'm at, and then I say, okay, I'm trying to find y, right? So I go back and look at my equation, which was right here, but now I know C, so I write it down. So I'm going to write, look at your paper, correct me if I make a mistake, Greta. So I've got 1 all over, is it 1 minus y?
The first one.
No, this one here, sorry, my bad. This one here, y minus 1.
Y minus.
So negative 1 divided by y minus 1 equals 1 over pi sine of pi x. And now the value of c is known, that's plus 1. Shoot. Plus 1. Are you good to there? Okay, if you get to here, you've earned 5 points. If you can't do anything else, you've still earned 5 points.
How long do you normally take the course with this and the FRQs?
So, I have to make, before I ever answer that, I always want to make something clear. Raise your hand and answer this, extra credit for everybody. If you want to score in the high 20s or higher on the ACT test, like high 20s or higher, like you get a high score. I don't have a question, I'll just tell you. You have to get most of them right. Like you cannot miss very many questions on the ACT and still score high. Nod if that sounds familiar. Okay. The AP test is completely different. This is 55% of this, approximately. Maybe exactly, I don't remember, it's close. So you can miss like almost half of the questions and still get a 4. And with a 4, you earn, for all the universities I've checked, the maximum amount of college credit. They don't give you more credit for a 5, they just, it feels good to do as good as you can do, but you don't have to. Okay, so it's very different than the ACT. The ACT is a race. You have to go fast. You have to learn to go fast. You should not go fast on the AP test. If you go fast, you will score worse. You should go slow, carefully, reading carefully, understanding, comprehending, and just working. And it's like Greta said, if you're working and suddenly like, I don't know what to do, like I just know I'm stuck, you just move on and do something else. So no one ever complains about the time limit for the AP test because you're approaching the test differently. You don't try to get everything done. You don't say, oh, I've got to get it all done in this time limit. No, you just work for the time, get as much as you can. But the time limit is, the first section of the test is 30 questions, multiple choice, no calculator, you get 60 minutes. From past years, hearing from students, that section tends to be a difficult section. And so students who can get like a third to half have actually done very well. So that sounds terrible, but on that first section you got an hour, trying to get through about a third to half of them. And don't stress about it. Just don't race, do not rush. Just work, if it's confusing, move on to the next problem. If that one's confusing, go on to the next one. If that one's confusing, go on to the next one. Okay, I've seen lots of tests where question 30 is not hard, question 17 really is. So I don't stop, I keep moving. But you get 60 minutes for 30 questions. The second section of the test is multiple choice, 15 questions. You use your calculator, you get 45 minutes. Most people have reported in past years that that section's a lot easier. Now maybe this year it swaps, I don't know. And so they'll come back and say, wow, like I think I missed one in that section, okay? So, but you just do the same approach, just keep moving, okay? Then they have FRQs, there are 2 FRQs, you get 30 minutes with your calculator, then 4 FRQs, you get 60 minutes without your calculator. But during those 60 minutes, you can actually work on any of the 6 problems, you just can't use your calculator anymore. That's the entire test. But don't worry about the time limit. It is not something you want to worry about. You want to practice, just keep moving, but not racing. You get in a hurry, you make mistakes, you read the problem wrong, you get confused. Just go steady. Question? Cool. Come back to here. Okay, we've done the separate, we've done the anti-differentiate, we've done the constantate. All the words must end in the word ate, apparently. hence the invention of the word constantate. So what's the I stand for? Linear rate makes sense because it's calculus, but that's the wrong direction. We're trying to go from here to here. We've already done that. We've already done the anti-differentiate. We're trying to get an equation that says y equals. Say it. Isolate. What are we trying to isolate? The y. Triumph. Triumph. Trying to isolate the y. It makes sense. I know constantate's kind of goofy, but you know, it goes together somehow. Questions? Okay, gotta get the y alone. Look here. Okay, with algebra, practice doing algebra in chunks. Don't do algebra with little tiny pieces. Like, look at big chunks. So what I see here, I have 1 over y minus 1 equals, who cares? Just a bunch of stuff, right? So I'm going to multiply both sides by y minus 1. But then I'm going to divide both sides by a big chunk. So in one step, I can get this. Negative 1 over 1 over pi sine pi x plus 1 is equal to y subtract 1. If you can't see how I did that, just wave at me and I'll show you another way to look at it. But you want to learn to do algebra in chunks, not tiny pieces. It's just faster, it's easier. We need to talk about that step.
So you went back to, sorry.
You're good. So when I look at this, what I'm looking at is, stay with me, Mario, what's the goal? Isolate what? Y. So I look at this chunk and say, well, there's a y in this chunk. There is no y in this chunk. So I want to get the y in the numerator. So think of it like this. All I really have is negative 1 divided by y subtract 1. Just read the name for me.
Can I just grab some comments to interview her for your book?
So you have this, Mario. And all this stuff over here, I don't care what it is. So I'm just going to call it A. So what I do is I multiply both sides by y minus 1. And then I divide both sides by A. That's how I got to here.
Okay, so it like perfect sense to me, but why did you lose? You went back to, so after we found C, you went back to.
Oh, gotcha. So remember the big picture was, it gave me this equation, I'm trying to find this equation. So I did separate and to differentiate. That gave me this equation right here, which is the equation I'm looking for. There's only two problems. I don't know C, and I don't have it rearranged.
Okay, so just go back to that one, 'cause that's like.
Right, that's what I want. Yeah, that's what I'm looking for. I'm looking for this. With me? I just kind of pause to find C. Once I find C, I go back.
Why wouldn't you just get y by itself at the very beginning? Because if you're trying to find y and then then find c after.
Hold on.
Or can you do it that way?
So are you saying that we had to separate, you see that? We had to anti-differentiate to get rid of the dy and the dx.
Yeah.
With me there? Once I get to here, you're suggesting let's solve for y, because that's the goal.
We're getting y, then we kind of get y, and then we go find c, and then we come back and then finish getting y? I don't know.
Hold on. Everybody look up here. Everybody look up here. This is a very exciting moment. Everybody look up. Please note the award. One. Okay. Look. fun thing is, the reason I like doing this is because you actually have no clue why you're getting so much.
Yeah.
Just know it's a good question, right? Here's why I'm giving her 3. The logic is perfect. The goal is to find y. Like, let's go solve for y. And if you look at the answers in the back, that's often what they do. They'll go find y first. Here's why I don't want you to. And you can answer this. So 3 tickets if you can answer, otherwise we start taking them away. No pressure. You can do it. No pressure. The separate step. Okay, so first question, can you see that it really doesn't matter? Like if I go find C first, and then I rearrange to get y alone, I've accomplished my task. Y is alone. If I did it the other way, I went and found y first and then found C, I'd be done just as well. Does that feel good?
Yeah.
Okay. So are you okay that either way really does work?
Yeah.
You're awesome. Here's why you get 3 points, 3 tickets. Separate is always worth 1 point. Anti-differentiate is always worth 1 or 2. Constantate is worth always 2. Isolate is always worth 1. So why do I want you to do the constantate step before the isolate step? So I'll say it one more time. This is worth 2 points. This is worth 1 point. That's what I was saying to Greta.
Because then you'll miss one of the
I'm not saying it very well. It's my bad. It's my bad. I want you to do the constantate step first. You see it, right? Tell me why.
Because it's worth 2, so you gotta get 2.
Yeah, because what Greta said. If I get to here and I find the constant, and I can't figure out how to keep going, I've only lost 1 point. If I try to isolate first and I get stuck, how many points have I lost? 3. So is it logical to find the constant first?
Yes.
Yeah.
So it just helps you.
I'm just trying to get points. Yeah, see what I'm saying? Yeah, I'm trying to help you just get points.
Yeah.
Good work. Okay, that's your question. Awesome. No, the thinking is perfect. It really is. But I just, more points the better. So I disagree with the way they do it. Like in the back, they'll often isolate first, then find the constant. I'm like, whoa, wait a minute. If I find the constant first, I get 2 for sure, maybe the third. If I try to do it the other way around, I might lose all 3.
How would you isolate this one? How do you take constant?
Same way algebraically, it's just a little harder because the fact that this is it's really not that much harder. I mean, you do the same thing, like multiply this across, divide this over here. It's more like I just want to get the points when I can. So the 2 points, I want to get as quick as I can.
But if you don't know C yet, how would you find Y?
Oh, you move it, so you get y alone, and there's still a c over there, and then you just plug in the find c.
Oh, okay.
That's your question. So back to here. Last thing is add 1. We're done. So y equals this whole mass. Simplification is not required on the AP test, so I can stop now. Question? Brittany?
So I got that same thing, and I checked the answer at the back, and with the denominator, it has 1 over pi sine pi x plus pi.
Hold on. Let me look. Copy that. Let me solve this. Well, it's but they also have a pi in the numerator. All they've done, I have to write that down to show so So they have, the video won't show this. So apologies to those who are now watching the video. I told Cameron Cardin that I would try to, in one of the videos, whistle like I have a habit of doing, and then call her dog, whose name is Daisy. She said when I whistled, the dog kind of perked up, like, what? Who's whistling? So, come on, Daisy. Come on, Daisy. Okay. See what happens. I don't know. Freak out the poor dog. Come on, Daisy. Okay. Anyway. I don't know why I'm waving. They can't see me. All you see is the screen and the voice. Dog's like, what's going on? Come on, Daisy. Okay, this is negative, just like this is negative. You see that written? So this is negative, just like this is negative.
Yeah.
The one is positive. So you're good with that, right? Good. All they did is they multiplied top and bottom by pi. So you end up with a pi here, the pi distributes, that one goes away, and you end up with 1 there. Yeah, not required, so I don't worry about it.
So like the written section that would work through once it-
Done. Drop, I don't want to drop any breaks. I really dropped it before it broke. Set it down. Okay, set the mic down and walk away. Okay, it's not very dramatic to set the mic down. Okay, I'll stop talking. Question? You good? You guys are very polite to smile when I start losing my mind up here. Okay, stop the video. Stop saying all this random stuff. Yeah, I did some wacky, whatever. Okay, stop.